myself first. I'm Jettro Coenradie. I work for Luminous Amsterdam. If you want to know more about me, you can follow my Twitter or you can check my LinkedIn page. If you want to know what I'm doing, well, mostly in the evenings, then you can check my GitHub page. And if you want to know what I'm doing in the weekend, then you can check my Flickr account. The picture is a bit off. I know it is the moon, and the moon is kind of round. Well, and I don't think it's round here, so bear with me. In reality, it was round when I took this picture. It's still a hobby of mine. But we're not here to talk about pictures. So let's start discussing what we are here about. We're going to talk about getting data, extending the data, and presenting the data. And we're going to do that using the ELK stack. It's all part of the data lifecycle, as we call it. So we start with getting data, then we'll move on to extending data. Next step, storing data. I will not talk a lot about storing data. If you have more questions about that, then come later on to me, then we can talk about it. Did anybody visit here the first session by Roberto about Service House? Okay, a few. Okay, so there's already some people that have learned about Elastic a little bit. Well, this is what I'm going to talk about the Elastic toolset and a little bit more. So I also discuss a few things I did outside of the Elasticsearch toolkit. So, who has heard about ELK? Everybody. Oh, cool. So I don't have to do a large introduction, I think. Who is already using it? Yeah? Okay. When you learned about it, what did you start using it for? Was it log analysis? Yeah? 1, 2. Search? Analytics? That can be. I mean, everybody said it was using it, know it, and nobody tells me what he started it for. Okay, let's just continue. Getting data. Well, first, let's talk about getting the data. If you talk about the ELK stack, the first part would be Logstash. With Logstash, you can already do quite a lot in getting data. You can, of course, read in log files, which it all started. But you can also do JDBC, so you can import data from a database using JDBC. There's also an interesting one, the third one, JDBC backup file. We will talk about that later on, and you can also index even Twitter with Logstash. Not completely part maybe of the ELK stack in the abbreviation, but it is an Elasticsearch product called PacketBeat and TopBeat, which is kind of a new kid on the block. With that you can send data to Elastic from remote servers, but you can also monitor servers, so you can do CPU time, hard disks, all these kind of information. You can send it immediately from the servers back to Elastic. It's an interesting product range. And the final one is, of course, custom components. So you can write your own custom components to read stuff from somewhere, from your application, from an API, maybe user entry. There's all sorts of things that you can do. You can do that using Java. You can also use node.js, Groovy, Python. There's lots of things that you can do. For now, I will show some Java and I will also show some node.js. So what we will do it with? Well, we are at a conference, and I also have a conference called Crowd Control. And this is a website. You recognize a website? Maybe not that good at drawing, but you can enter your name, email address, and then you can push that register button. Well, usually maybe you have to pay something, but since if you're a member of the JUG, you can enter for free, so my conference is free as well. Then the people that registered for the conference, they at a certain moment, they go to the conference. And now we want to control them. Yeah, this is control. The doors are still closed and then everybody goes in at the same time. Well, here we have the early bird sessions to control it a little bit, but we wait for the people to come. And when they come, they enter a room. And what we would like to do is monitor the flow of the people, how they go into rooms, which sessions they attend, and make that visible. How do we do that? Each room has a sensor, and with the sensor we detect if someone enters the room or someone leaves the room. That's the information that we have. So how could you do that? Well, the sensor could maybe write to a log file, and we use Logstash to monitor that log file, and we send it to Elastic. Of course, there are lots of other ways to do it, but for now let's keep it simple and let's do it this way. There's 3 important fields that we have. We have the room number, we have the timestamp, and we have the action. And the action can be like +1, or maybe if 2 people at the same time enter it, we have +2, and it can be -1 if someone enters the room. That's the events that we have. So we use Logstash. Let's zoom in a little bit on Logstash. 3 big elements in Logstash. The first is input. With input you can take files, you can read database Twitter, we already mentioned that. Then there's the second one is filter. And with filter you can use a number of things. You can use a grok, which does some kind of pattern recognition. You can drop lines with other patterns, and you can combine lines. There's lots of things that you can do in the filter block. And there finally is the output block. And with the output block you can write back to a file, you can write into Elasticsearch, but you can also send it to, for instance, Kafka, or maybe just debug to the console out. Well, you already saw the website, and in the website we run it on Apache, so we have some Apache logs. Anyone not familiar with this? You don't have all the details, but it's not that hard. If you start reading the line and you see the different components in there, it's okay to follow. But it's not like if you would enter this and you have to go through it yourself. That's not the way we want to do. We want to have more control. We want to have more information. We want to have a timestamp. We want to have the IP address, and we want to know which browser someone is using, maybe which URL they visited. It's all in here. So let's start with the input of Logstash. This is how the input could look. It would point to the file, and in my case I would say start from the beginning, which would mean that if you have a prefabricated file that you would just immediately import at the same time all at once, then you would start from the beginning. If you would monitor it and just would enter new lines that would append, then you could lose the start position. You can skip it. Let's zoom in on the filter. So this is a grok, and this is coming out of the box with Logstash. This is a grok filter with a pattern that's already available, and it's called combined Apache logs. So what it does, it takes that message and it would break it up in all sorts of fields like IP address, user agent, and all interesting stuff for you that you can do. That's this part. You could write your own pattern. But yeah, if you use a standard out-of-the-box Apache HTTP server, then this is what you can use because it will just work. And then the second part in the filter is to do some date matching. By default, Logstash would insert a timestamp in each event it will find, but then it would insert the timestamp of when it was imported. But we want to have the timestamp that when someone visited the page. So in this case, what we do is we look up the field in this called timestamp without the @ sign, and we have a certain pattern in there, and we would then put it in a specific field called @timestamp, and that is the one that we will use later on to see when someone actually entered the timestamp, and you can use that in your presentation part as well. So it's a trick to make it clear that from the log perspective you know when someone visited a certain link. Well, then we want to send it to Elastic. In this case I have 2 outputs. The first output is the Ruby debug, it's just the console out. So you can see what's actually going there in your console. It's easy to debug. And the second one is the most basic way to send stuff to Elastic. So we use the HTTP protocol and we send it in my case to my local machine. So if there's nothing hard to do, then you can just use this. Okay, so now we have the statistics of people entering our website, and we also have an order entry system where we track the registrations. But this is in the database. And the database and the website are not at the same site, and I cannot really easily access the database from my local machine. So what do? You could create a dump file, of which you see a little bit, just a small part of the dump, of a MySQL dump. Well, you could then run MySQL on your local machine, import the dump file, and then read it using the JDBC import. But this guy, David Pilato, he had a very interesting blog post, and he showed that it's actually also possible, without having a database running, without MySQL running, to just take that dump file and use pattern recognition on it to read it completely without importing it first into a database. And I thought that it was very interesting, so I'll use that. This is, This is the most interesting part, the insert into. What it says, insert into the table registration, and then it has all the events of people with the email address, their name, the date they registered, and their zip code. So that's what we want to put into Elasticsearch. So we take again an input, which in this case is standard in. So it will read from the command. And we do some interesting stuff with Linux. Cut dump, so you take the whole file, you dump it to the console, and then you skip the first 40 lines, and then you take one line, and then we port that into Logstash. So what it actually does, it takes that one insert into statement, which contains all the rows, and it will put that into Logstash. So that's what we start working with. So that is this part. This is what we see. So how do we do that? This is the whole configuration for the filter part. So the input I already showed. This is the filter part. First we do some pattern recognition. So what do we do here? We detect if it's insert into registration, and then with the greedy data we take everything else. So we skip off the insert into, and we just have left the comma separated string with all the fields in there. And then we split it because it keeps the curly braces in there, and we split it, and then we get a lot of more rows. And then we have to do some mutation. We take the first round that's still in there, and the last one we take it off. And then we use the CSV filter, and the CSV filter now takes all these insert intos, so these records, and it will create separate lines for it. So if you would have like 1,000 records in there, then in this case now you would suddenly have 1,000 messages instead of just one. And then in the end there's also a version host where we just remove it because we don't need it. So now we have all these events, and each event has an actual object in there with the registration information that we obtained from the database file. And then we can put it into Elasticsearch. Well, in this case we do it a little bit more complex. We still keep the HTTP protocol. The host is still localhost, but now we also specify the index it's inserted into. Usually it's the Logstash index. Now we specify the index we want to have it. We also specify the document type, and we specify a template. And what the template does, with that you can, this one is what we already did. And with the template you can specify like a database schema, sort of. So you specify the fields that it can expect and what type it has. You don't need to do it for Elasticsearch, but if you want to do more specific things like recognize dates, or if you want to analyze fields or maybe not analyze fields, then a template comes into use. And with this you can make Logstash manage for you that the template will be available in Elastic. Okay, so this is what a room event looks like. A timestamp, the room ID, and the action. Now we continue with that. Again, a file, events log. Just lost a little bit. I think we already got these parts. Yeah, okay, so this is another way. Sorry about that. This is the way in the end I did it. So in the end I didn't have a database, but it was more like you can do it with a database. The other part I did because I don't have the conference yet. The conference is taking place at the moment, so I didn't have the log, so I generated a log file. And the log file just looked the same like the database events. And there we do again the date matching like that we discussed before, and we again have the Elasticsearch stuff. So now in the database we have, or in Elasticsearch we have the registrations, and we have the website logs. So we now know that someone was on the website, and we know the people that registered in the end for the conference. So now we want to extend the data. We want to do more interesting stuff with it. So a question could be, where are all the people that are coming to my conference? Where are they coming from? Well, we had the zip code, but the zip code is a bit hard to use to place it on a map. You need to have other kind of data to place it on the map. So what can you do? In the Netherlands it's possible, you can use web services, but there's also a file that is like 2 or 3 years old, I think, where you can just have all the zip codes that are in the Netherlands available, and with that you have the longitude latitude, so you can look up based on the zip code and you can find the longitude latitude, and with the longitude latitude you have the coordinates to put it in a map. So that's what we do here. We read all the zip code information into Elasticsearch, and then for each zip code we do a query in Elasticsearch, and what we get back is the longitude latitude. We could also add the province or the city or a lot of other information, but for now, to just plot it on a map, the location information is enough for me. So how would you do that? More code. This is all the code that you need. First you have to do a search. We have a search registration, so we have an object that contains the zip code, and then we use the registration class to make it like a query object, and from that object that we have, we obtain the zip code. So first we have the search registration that we got from a search. It says there hit.getSource as string, so we already got it from Elasticsearch. We move it into an object which is the search registration object, which contains the timestamp and the zip code and the name and the email. So we obtain the zip code. Then using that zip code we go to the postal code index, and there we find the location and the latitude and longitude information. So we first do the query, we get a response, and in the end we check if I found the location object by doing the hits from the index. Again, a source as string to just do some mapping. That is just easier to the object mapper to make it a Java object again. And then the postal code get location obtains the location. And then in the final part, what we can do, we can add that location to our registration object, and then we can do an update request. So these are the steps that you can take if you would do it on Java. And then as a preview, what you can do is you can print this using Kibana. And then you can look like a heat map where people are coming from. Since this is generated data, it's not like the reality, I think, for the conference, but it's still interesting that you can do. But what if this is not what you would really like? I mean, it's nice that you can do like a heat map, but it's hard to, if you want to do an advertisement campaign in a certain province, maybe you want to know which province people are coming from. And based on the location data that you have, you could determine that. The easy way would be to use that zip code information again, because the province is there as well, but that would be a bit too easy for this use case, because I want to show something called the Percolator. And what the Percolator is, it's like an inverse query. So in Elasticsearch what you can do, you can like store the query and then provide it with something, and like a location for instance, and then see which query would match that location. And then you can do interesting stuff with it. So you could attach things to the query. So to make that a little bit more clear, these are the coordinates that we have. This is the longitude latitude for somewhere in Amsterdam, which is here. And what I would like to know is like, this is north of Holland, the province north of Holland. How would we do that? Okay, let's. This is a specification for a query. What this does is we're going to create a shape, a geoshape. And the geoshape is just a number of points, and the shape itself connects the points with lines. And then you can see if a certain point is within that shape or not. And that's our query. That's what we're going to do. So for each longitude latitude that we have, we can then check if there's a query with a shape in there that would match that point, and that would give it back. And then we can print something with the province. So how would you do that? More code. First, we're going to create the index. So we're going to create a polygon, which is just a number of geopoints. And when we have this polygon, we are going to create a filter, because we don't need to store the polygon, we need to create a query. Well, in this case we are going to use the geoshape filter, And what it does is it creates that shapefile, and then it can see if that point is within the shape. That's what we do here. So yeah, and this is in Elastic prior to Elastic 2. You still have a difference between filters and queries. So I guess, is someone already working on Elastic 2? Okay, so you have to be careful with the examples because they will not all work. You have to migrate them a little bit. But with a filtered query in Elastic prior to 2, you have to do a query and a filter. So we just do a match all and the polygon shape filter. Well, and then we store it. It's just like any other document that you can just store a document. The only difference, it uses a specific type, and that's the dot percolator. So you should not use dot types yourself because they are more for Elastic internal work. But with this, you know that you store the actual query as a document in the same index that you will store your own documents. And the ID that we give it is important because the ID is what you can use. So if you would do a percolator attempt, it would return you a number of queries that match. It would give you back the IDs of the query. So this is important. Based on this ID, you have to be able to identify yourself what you want to do with it. So for me, I want to know which province it is that is actually matching in the query. Well, and here we use that code that I showed on the previous slide to create the actual query, and we store it in the index. Well, and how would you use it? There is a specific endpoint, the percolate endpoint, and you can provide it with a document and the location with the latitude longitude. That's the only thing that you can do. And then it will go into the backend and it will try to match the province that you are in. And in this case, I have other latitude longitudes as example. And in this case, it found the province Gelderland. So now we know which percolated query, which query matched my actual longitude latitude. And then with this index, we can go back into the percolator index, and then we can ask for the actual data points that are in there, and you can plot it. Now, that's what I want to show you. Now, I hope this works. Yeah, it works. So here I use in the backend everything that I've shown so far. If I would click one of the cities in here, where is my... Then it would now check that coordinates that are on the left, would send it to the backend, and then it would get back province Zuid-Holland. And then what I would do is I go back to the service and ask for the shapefile, and then using leaflet, it can accept that shapefile, and you can print on a map the actual shape. And that's what we're now able to do. Okay. Next step. So we have now more information. We know where people are coming from. We can plot them on a map. We can tell them which province they are from. But what we now would like to know is if someone registered, we want to know what they did on the website. So we have this website log. We know which pages they visited. And if they registered, we know that somewhere in that page there needs to be a link called register. But we want to know more about that user that came in. So we would like to know when did he start visiting our website. We want to know whether he did register or not. We want to know the amount of pages that he visited. And maybe we want to know how long he was on the page. That's what we call summary data. So what it does, it takes a different set of documents, maybe based on IP address or session ID or what you can use, and then create a summary out of all those documents. So you could enter all the URLs that are in there, and you can use the times, and there's lots of stuff that you can obtain from all these different events. So this is a schematic view. We have the Logstash index, we have some records in there. Then in the application, we go through all the records, and we would do a scan and a scroll. That's the way in Elastic that you can go through a lot of number of records. And we would use a certain thing that's what's called the upsert script. And the upsert script is something that can be, for instance, a JavaScript file. It can be a Groovy-based script, and you store it in Elasticsearch. And in Elasticsearch, you can then read that script the moment you provided a document. So what we can then do is we go through all the log statements, and then we loop through them, and we pass it to that upsert document, and then we would create a summary doc out of it. So how would you do that? First, a little bit information about the batch side. I think I'm going to skip this for a little bit. Yeah. Okay, so if you want to do a batch update in Elastic, it actually consists of 2 lines. First, you have to tell it what to do. In this case, it's an update. And the second part would be the document that you are actually going to use. Important here is that we upsert with an empty document. This took me a while. That's because we use a scripted upsert, but if you don't provide it with an empty document, you get an error. So you can use an upsert with the document as well, but in my case I use a script, but you still need to provide this. So if you're ever going to do this yourself and you get errors like empty docs or whatever, then think about this line. Then we provide the script with a parameter called log, and that would be the hit source. So we browse through all the log files, so all the access logs, and then each time we find a log line, a log event, we will send it to this script, and we pass it the log file, the log line. This is we tell it that the script is in a file, and we tell it, in this case, JavaScript, and we do a scripted upsert. That's what we tell it. So you have to use a script to upsert that summary document. And then this is the script itself. So the first line, we obtain the source of the current document. So now it's a bit difficult because we have this summary doc, which is in a separate index. This is the doc. So that's the summary doc that we're updating. This is, for instance, in my case, it's based on IP. So for each unique IP address, we create a summary doc. In the second line, we check if the doc is already there, and that's what we do that based on the number of pages. So if there's a number of pages, then we know that the doc is there. If it's not there, we set it to 1. We log a start time, an end time, and a visit length of 0, and then we continue. So the first time an IP address log comes in, it will go here, and it will actually create the summary doc. Then the next time a log line comes in with the same IP address, we will add the page. We'll make it 1 more. We will check the current time, and we'll check if it was before or after the previous one, and we will change the start and end date and the current date for that. And we can change the visit length as well. And this is an important part. What we do here is if we check whether the log line contains the word registered. Because in the URL where you register for the event, there's at the end registered. So if this is in the line, then we know that that person with that IP address actually registered for our event. So in the summary doc, we can now all say did register is true. And that's what we take here. But now we want to couple them. So now we have the summary doc of all the logs. So we know that someone with an IP address visited our page, visited 10 pages, and in the end registered or not. But we also have this other index where we have our registrations. And how can we couple them? This is the information that we have. There is no direct coupling between the logs on the website and the stuff that we have in the registration. So what did we do? We used the timestamp, which is kind of, riskful. If you have a very successful conference and you have a lot of people that register at the exact same second, then you're lost. Then you cannot connect them. But the customer that we did this for, they had like 3 or 4 registrations per hour, so it was very well possible to make this connection. So then what we have is now we have we know that someone who registered, what he actually did on our website, because we combined them using this URL and the timestamp. Well, I already promised you I would not tell a lot about storing data, so I have no additional slides for this. Let's move on to presenting data. First, the web loss. Kibana. So how many of you have seen Kibana? Quite a lot. So you already seen these kind of images. And you know that from Logstash you get the location information as well. So you can show your visits on the map. You can tell the actual registrations that you have. For instance, these are things that you can do. But with the geo stuff, we already saw that Kibana could do this. But we wanted to do more. And we wanted to do this. Well, I already showed you the demo. This is done with Leaflet, a D3-based library. It's also the library used by Kibana itself. But it's very configurable. You can do quite a lot with it. So if you want to do a little bit more with the way you show your data, for instance, for a customer, what we did is we colored all these provinces. So if there was like 5 people coming from one province, it would be light yellow, and then it would turn into red the moment you had like 100 registrations. And that's easy to do with this technology, because you know that you can very easily plot the provinces and you can make the colors yourself easy as well. Then the sensor events. How can we present that? So now the next step is what we actually would like to do is know how many people are in the room, because that's what we want to plot. We want to see, like, at that moment so many people are in the room. So can we do that as well with Elastic? Well, you can use a date histogram. And date histogram is an aggregation in Elasticsearch. People that don't know aggregations? Everybody knows aggregations, facets, okay. So you create buckets. In this case, I just plotted 4 buckets, and I created buckets for each 5 minutes. Well, then we want to know it by room. So below the date histogram aggregation, we would create the term aggregation. Then we have these kind of buckets, so we have the bigger buckets for the times, and then we have the smaller buckets for the rooms per time. But we want to have a count, because we want to know the amount of people. Well, the default count that you would do is not what we would need, because the default count would just count the number of events. So we don't know how many people entered or left, we just know that we have, in this case, at between 10 and 10:05, we have 10 events. But we still don't know how many people are in the room. And that's what we want to know. So if we would show this in Kibana, it could look like this. But then again, it's the same thing. We still have the amount of events per room, but it's not the answer to our question. Well, then we can use another type of aggregation, which is the sum aggregation. And with the sum aggregation, you can do counts. And you can also do summations. So we know that in the event that we have, there was a field called action, which was +1 or -1. So if we would sum them up, if one enters the room and one leaves the room, then we still have 0. So we're getting closer, but it doesn't keep track of history. So if between 10 and 10:05 we have 5 people entering the room, and in 10:05 and 10:10 we have 10 people entering the room, we still don't have a plot of how many people are actually in the room. But that's what we want to know. We want to know that there's 15 people in the room. Well, this is not really easy in Kibana. Well, it was not. No, it's still not easy in Kibana, but in Elasticsearch it was just not possible. So you have to create an application to do this. You have to have an application that would do that aggregation query, and then it would keep track of the actual people in the room. So you would just start at your first time, and then you would go through all the events and you would count them up, and in the end you would know how many people are in the room. And that's what I did here. This is the floor map, and what we're now going to do is see what happens. So I push the play button, and below you find the time. It's getting light blue, then suddenly everybody enters the room. Now it's in the early bird sessions. People enter the main room. and you see that the time is running, so it's continuing, everybody's in the keynote, and then suddenly everybody goes back into the foyer again. This is what you can do. So this is a way that you can use Elastic to do the date histogram. You can divide it per room, you can do the summation, but then you have to keep track yourself a little bit of how many people are actually in the room. Well, you can see during lunchtime and all the stuff what happens. This is a data presentation, a way of presenting the data, well, in another way than just numbers. But what's interesting is that 1 or 2 weeks ago, Elastic 2.0 came out, and there is an interesting feature in there called pipeline aggregations. What are pipeline aggregations? With pipeline aggregations, you can actually do what we just did. So you can keep track of history. So you can take these buckets and then do calculations on the buckets again. So if your first bucket contains 5 and your second bucket contains 10, then with a pipeline aggregation we can take these buckets and do an additional step and then do a summation of those again. So then we do have all the data in there and we don't have to have an application that would keep track of this. So how does it look? It's a long one. This is an aggregation. We start in this case with the room. So we don't do the histogram first, we do it first per room. And there's a reason for that, because the pipeline aggregations, they don't work well with the terms aggregation, because it's not a number. It wants to have numbers there, and it's easier to do it this way. So we first divide all the big buckets by room, then we do the date histogram. So we track in buckets of 5 minutes again how many people entered the room, or well, actually how many events we had. And then with the sum aggregation, we would track how many people entered the room, left the room at the same in the same interval. And then we have the pipeline aggregation, which in this case is called a cumulative sum. And there we would say, like, take the people in the room path. So now we point it to the summation of the aggregation before, and then we say, like, hey, do cumulative one. And now what we would get in the result is that at a certain moment we see a doc count 42, so there's 42 documents in there, 42 events. There's 42 people in the room, which makes it a total of 42 people in the room. But then in the next event, the next 5 minutes, we would have 41 people in the room, but we already had 42, so in total we now have 83 people in the room. And with Elastic 2, it's now possible to do this in one query, which is really nice. Well, that's all the steps that we took. So we went from getting the data, we took the log files, we took the registrations, we combined them in a summary index, and we did that using Logstash, we did that using the JDBC parser. Extending, we did the zip code database, we got location information, and we did something with the provinces. And then in the presenting part we did a little bit with Kibana, and we also used the D3, the sample that I showed you with the floor map is a D3 sample. So it's based purely in, done purely in D3. Well, that's about it. This is for the company. If you want to race, go to the Luminous stand and you can win this droid. And then the one that you have to rate the talks. Are there questions? No questions. Then it's time for coffee or tea, I guess. Okay.